that I mentioned this. So from today on, or from this lesson on, two things will cost you if you don't do them right. One is, the main one for right now anyway, is that your program has to run more than one time. In other words, the program has to run until the user says, no, I don't want to continue on. Okay, or to put it the other way, to negate that, the program should run as long as the user wants to continue running. As long as they answer yes, or whatever else we deem to be the key to continuing, the program should keep running. If it doesn't keep running, that's a major error and it will cost you substantial points. Okay. The other one that we want to do is, up until this point, you should realize that if you were asking, let's say you were asking somebody to get their age and they typed in a letter instead of a number, your program crashed, which is not a good thing, especially because, you know, right now we can get into the programs and stuff like that, but if a user had your program and it was an executable file and it crashes, I mean, there's no recovery for them except to rerun the program. So they would lose anything that they previously put in. So those are the two big point taker awayers, whatever you want, the two big errors, okay, is that your program only runs one time, and the other one is that your program crashes. And the first, or not the first thing, but one of the first things I do when I run your programs will be to type in anything I want and see if your program can handle it or not, okay? But I'm going to show you how to fix all those starting out today. And then we're going to write a program. But before we do that, I want to take a little bit of time and just kind of go over the three main keywords that we use in Java anyway to for loops. Okay, so let's take a look at that. I'm going to share my screen with you guys somehow here. There we go. Let's do this real quick as long as I'm here. You should be able to, do you see that now, Tristan? Tristan, are you with us, or did you just log in and then go out to lunch? Okay. Melissa, can you see this?
Sure can.
All right. So the three programs this week are listed here. Notice again that it must run multiple times. And you have to be able to get out of it too. You can't just keep running forever. You have to have, and I'll talk more about how you do that in a little bit. The first one here is changing a binary digit, or a decimal digit, into a binary. In other words, base 2, from base 10 to base 2. The math to do that is what I've got here. You take the original number, let's say it's 247, divide by 2, you get 123, and you get a remainder of 1, okay? Because 2 times 123 would be 246, plus 1 is 247. What I'm keeping track of for the most part are the remainders, though, okay? Are the remainders. So how do you get a remainder?
The percent sign.
Yep, the modulus, right?
Yeah,
the
modulus.
Percent sign. And then the next one I do is I divide the 123 by 2, get a remainder of 1, et cetera, et cetera, et cetera. Sometimes you'll get 0, but you can only get 0 and 1 because you're dividing by 2. If you take the remainders backwards, it becomes the binary digit, the equivalent of 247, because I've got 1, 1, 1, 2, 1, 4, no 8s, 116, 132, 164, and 128. And that's how your computer works too, if you didn't know that. This would mean this circuit is open, this circuit is open, circuit's open, circuit's open, circuit's closed. Circuits open, circuits open, circuits open. If you get one, if you were to end up your answer being 11101111, you have it backwards. And of course, that isn't equal to 247. So what you're going to do is do the math, and you're going to append, instead of appending to the end of the previous calculation, you know, like in a string, we append, right? Usually on the end of the phrase or whatever it is. This time you're going to add to the front of it. So all you do is put the variable first, then your two ampersands, and then the variable name that you're saving to. So you want to append to the front to get the right number, because if you don't, you're going to get it exactly backwards, and that'll cost you. Next one's pretty easy. I want you to roll heads and tails. So again, your random number is going to be what? John?
It'll be out of 2.
Out of 2, that's right, because you're going to get 0 and 1. And so you can make your heads 0, your tails 1, and I want you to roll it 1,000,000 times, or flip it 1,000,000 times. Now, when I say that, I don't want you to print out your flips, okay? All I want at the end is it says I rolled this many heads, this many tails, okay? And they should add up to 1,000,000, okay? One thing to be careful for in that one is you want to make sure that your initializations of your variables or your heads and tails are going to be inside your loop, because if you don't, you'll always get the same answer, because it won't run, you know, it doesn't zero them out if you don't. So your variables for heads and tails have to be inside your loop. Okay. And if, if you happen to mention, I can't think here, Rosencrantz and Guildenstern, and can use that somehow in your program, you'll get some extra credit points. If you don't know who they are, it has to do with, oh God, is it Macbeth? I believe it is. So if you look that up on Google it and find out who they are and what happened to them. It's a play by, actually it's a play by a guy named Stoddard, but it's based off Shakespeare, okay? And it's an interesting concept. It has to do with the fates, your fate. And Rosencrantz and Guildenstern, their fate doesn't look very good, okay? And the last one is the one we're gonna do in class today, and that's a math tutor for kids, young kids, because all we're going to use are real low single-digit numbers to produce that program. All right. Questions on the homework part? All right, blank worksheet. All right. So we've already looked at sequential, we've looked at repetition, and now we looked at sequential, we looked at decisions, and now we're looking at repetition. The three main keywords for repetition are while, do, and for. A while loop is a pre-process, or I call it pre-test loop. That means it's tested before it ever runs the process. Now, what do I mean by that? Well, Over here, we'll write, there's four, you should be familiar with these. There's four parts to a loop. First part, the first one, here, let me do this too, is initialization. Who's got their cat purring into their mic? That's kind of crazy. Or somebody's purring this morning. Initialization. Then we have tests. Then we have some type of process that we do. And then we have to increment. The one, guess which one people forget to do sometimes? Anybody?
Test.
No, it'd be hard to do. It'll run without this part. Oh, come on, guys. There's only four of them. Somebody pick one.
Increment.
Yes, increment is the one that people forget about. And if you don't have the increment right, you get something called an infinite loop. And that is not good. That means you can't stop it, or your user can't stop it from keep going. There's no way to stop it without crashing the computer, turning it on and off, or whatever you have to do. Okay. But those are the four parts. Normally we set some variable at initialize that. Then we test whether or not it's equal to that or not equal to that. Then we do, if we get into the loop, we do some type of process. And then last thing we do is increment, so that the next time it tests, okay, from increment, it usually comes back up here to test, and the value has changed, so that will determine if it keeps going or it doesn't keep going. So in a pre-test loop, that means the test is done before the process, and it may never run at all, depending on what that initialization was. Okay. A do loop is a post-test loop. So it will always run at least one time. And by that, I mean, we're going to use a do loop to put our whole program inside of it. Or 99.5% of our program will be inside of a do loop. Okay. Now the for loop, we're not going to worry too much about that right now. We will worry about it later because it's used a lot when we start working with arrays. But it's also a pre-test, but kind of. And people refer to it a lot of times as a counting loop, because it usually use that one when we know exactly how many times we want the loop to run. Okay, we use that one for when we want a program to run a certain amount of times. So you should be familiar with these. I gave you, there's some videos, not my classy videos, but there are some videos that I included in this week's lesson on YouTube that talk about each one of these. And I think for the most part, I got people that you're going to be able to understand on YouTube, which is sometimes a kind of hard to find. Any questions about the three different keywords or the four parts of the loop, or what an infinite loop is? All right. So we'll close that. Goodbye. Come on. There you go. Okay. So now we're going to do this one down here. So let's go over to our NetBeans. So here we are, and I'm going to create a new project. And of course, it's Ant. And I think I'll call this the Math Tutor. Now, again, this is a math tutor. It's not, we want the student to try and have to solve these problems. Okay. So my project is going to be called the Acme Math Tutor Program. And this will be Math Tutor. And then the date today is already the 22nd of September. And the author would be yours truly. Again, your guys would be your own name. And then the purpose, a program to tutor young students in the 4 types of arithmetic operators. 2 hours or 11 o'clock. 10:45, 11. Okay, so 4 types of, excuse me about that. That was my wife questioning me. 4 types of arithmetic operators. The basic numbers generated will be limited to the integers between 0 and 9.
You spelled arithmetic wrong.
I'm sure I did.
And limited.
Geez, Louise. What's wrong with my arithmetic here? All right.
The A should be an E.
The A should be an E. Wait a minute.
Yep.
Like that, right?
No.
No.
Take out ARITHMETIC.
No. Yes. It's morning yet. I haven't had quite a pot of coffee. All right. So let's see. Only there are no fractional numbers. There, whoops. There are, let's see, no fractions, no negative numbers. No fractions, no negatives. And let's see here. That's pretty much it. So I think that's most of the rules. Either somebody bought a lion or something. I don't know what's going on. At first I heard purring, now I'm hearing growling.
Yeah, I'm hearing it too.
All right, so if we move that over a little bit too, I like that. Move this down, cleaning all this up. I like this indented a little bit more here than what it normally is. So I'm about 3 tabs over on this one because I like to see it where I'm at and what I'm inside of or outside of, because it makes it easier for me to program that way. All right. Now I know that the student, oh, that doesn't make sense. A program, oh, it's a program to tutor young students. Okay, so I know I'm going to have inputs. So I'm going to have to import up here. Excuse me. And now my computer will lock up as soon as I type in scanner. That's a glitch in my program somehow. I don't know how that, and it always comes up and does that. And it does that. And then it puts abstract collection in there instead of what I actually had put in there. So, whoops. And I also know that the numbers that we're generating are going to be random. So that looks good. Now I'm down here. And I'll create my scanner. There's the growler again. I think somebody's sleeping actually. Scan student in new scanner, or their cat is, they're sleeping and their cat is using their machine. And then might as well go ahead and do our random too. That's why we're here. Okay, so a couple things I need. The first thing I'm going to need here, I think, will be char and let's make it oh, let's make it play again. Okay. And then I think I'll do a do. So in here somewhere will be my process. Okay. So here's my initialization. And I may have to put a value in there. So there's my initialize. Here is going to be my process is going to be in here sometime. And then down here, for right now anyway, I'm going to put a incrementation. So I'm going to say system.out.print. Enter Y to continue. Okay. Something to that effect. And then right here, we're going to have to so basically here, the student can type anything they want in. Okay. If it starts with the letter Y, that's what we want. But they can type in yak, they can type in yesterday, they can type in a capital Y, they can type in a lowercase y, doesn't matter. And this is where our test is going to go. So this will be while play again. Now play again has to be outside the loop. When I declare it, it can't be inside, because if it was inside, I wouldn't be able to see it here. Its scope would only be, if I move this down into here, I can't do this because this is outside. So this has to be outside my braces. So Y play again is equal to, these are single quotes because this is a character, not a string. And in this one instance, this gets a semicolon like that. Okay. Now watch what happens. I'll run it. And if I enter a Y, keeps going. Uppercase Y, yak, yes, Yankee, doesn't matter as long as it's a Y. I type anything else, a J, it stops. Okay. So there's my parts of the, here's my initialization, my process, my increment, and my test. My 4 parts of my loop.
Yeah, I think that's definitely a snore.
Uh,
I think that is someone snoring.
oh, that noise in the background is my dog drinking.
No, not that. I heard a snore
Oh.
right before that.
Yeah, I think somebody's asleep, really. The scary part is they got their mic open, you know? Okay, so some more variables. What are some variables we're going to need? Here, I know what we can do. Hang on one second. All right, here. Tristan, are you there? Tristan,
Yes,
are you awake or sleeping?
I'm here.
Okay. I'm just trying to figure out here who's sleeping and not.
Okay.
Melissa, you're there. Doesn't
Yeah.
sound like a girl anyway. John, you there?
Yep.
Sam?
Yeah.
Ian?
Yep.
Mason? Did Mason say yes?
Yes.
Okay. Gerwinder?
Yes, sir.
Zed?
Yeah, I'm here.
I don't know if I can get to everybody here on this. Yeah. Mason, Zed. Chris?
Awake.
Ben? Ben? Yo, Ben. Ben?
He typed
Ben
in
just-
chat that he was awake.
Huh?
He typed in chat that he was awake.
Oh, okay. Who didn't I call? Zed?
I think it's Paul.
Paul, are you awake? Paul? Well, I can fix Paul. I'm going to mute him. I think I fixed it, and I'm not sure. Okay, so hopefully that'll. Okay, come on. Somebody give me some variables we're going to need.
Will we have to make our random?
Yeah, but what am I going to put? Where? I can't do anything with them. I don't have any place to store them. Because nobody will tell me what the variables are.
We're going to need an integer to sort of count how many times the program has looped.
Space in there.
We'll also need another integer to count the number of correct answers.
I have 45 minutes to wait, or 40 minutes now. Nobody in this group has ever done math.
We'll need two more integers.
No,
for,
you don't. No, you already gave me two.
Do
Alright.
we have to have one to show how many were incorrect?
Nope. I guess I have to call on people because this is ridiculous. Let's see, who are we gonna pick on? Tori. Give me a variable.
Would it be one for like multiplication?
No. What is this thing for? What is this gonna do right here?
It's going
It's,
to generate the random number.
What random number?
Well, I think you said one anything but a negative, right?
Yeah, but where am I gonna store those? Because I can't do anything with them now because I have no place to put them.
Oh, wait. Oh, okay. So we need the two questions, the two integers that are going to have to be solve.
I'm going to need two integers, right?
Yeah, number 1, number 2. They're going to be random, right?
There you go.
Okay.
And once I have those, I need what? Need one more.
The
Answer.
sum?
Answer.
I don't know why it was so hard. My brain couldn't figure out what was supposed to be.
That meets our rule up here, does it not? 0 through 9?
Yeah. Oh, well, once yeah, but we're going to also get a 0. Well,
Yeah.
'cause-
You never done math where you got 0 for an answer?
Well, you
I
said
guess-
we weren't allowed to divide by 0.
Oh, no, well, that's only dividing.
yeah.
Yeah, that's why I was saying that.
Okay, but we need something more than this. We need a menu of some type. Before we even get to what I just put in, we need this. We need something that says system.out.print /n. Um, Let's do it this way. I think that'll work. And then we'll incorrect. Okay, let's call that. We'll go back up here and we're going to have one called int choice. Oops, not int choice. I want it as,
Would it be a char?
it will be a char. And it's going to scream at me that it says that. Okay, so here. Geez. So I got that. So that's my menu. So once I have that, I can drop down here. This is actually all the process. And then I'm going to have a switch to choice. Okay, and then I'm going to do the last one first, so this will be default. And this will be say. So now we don't need this because I replaced it with this. Let's see if it in fact works. I think I'll be okay. So if I type in the oh, what am I getting? Oh, those should have been backslash. Boy, oh boy. Type in the letter J. That's right. Okay. All right. I got all these backwards. So then I made the N's right and I made the T's wrong. Do, 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 do. Do, 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 do. That'll look much nicer. There we go. All right, so case 1, or case A, in single quotes, and we're going to go here, will be system.out.print. Will be num1 plus a plus sign, spaces around that, plus num2 plus an equal sign. Looks like that. And then let's make this a ln this time. Print line. This will be system dot. No, it won't. Oh yeah, it will. Okay, and then oops, that's not right. That's student in. Okay, so we can't do that yet. We're going to do that. Enter your answer. Okay, and so then it's going to be while not student in dot has next integer, like that. And this is the part that stops them from typing from the program to crash. That while loop there that I just set up. Now, if they type in an integer, this loop never runs because it's a pre-test loop. And so we will stick them in this loop until they actually type in an integer. And then we got to clear the memory. So we just type student int dot next. And then once they, it should be student in. Once they do it correctly, then we'll get their answer. Student answer. I thought that's what we named it, didn't we? User answer. Jeez. User answer is equal to student in dot next int. And then the computer's answer is equal to num1 plus num2. And then if user answer is equal to computer answer, and then correct plus plus. So
What
there's
does that correct plus plus do?
adds 1 to the correct. That's the same as doing this. Or the same as doing. All three of those mean the same thing. You can write it in any one of those, whichever one you understand. So it's either correct plus 1 is the new correct, or this also means correct plus 1, and this means correct plus 1 in Java. So every time we go through the loop, we want to add to the count, don't we? And I will leave that up for a minute, and I'll be back in a second. Okay, don't forget to put this up here, this count plus plus right underneath your do. And let's see if this works now. So if we type in a Z, let's say, okay, it exits. That's what it should do. Let's type in an A. Doesn't matter which way. And you get that, and I get a 9. Okay. And why is it stopping? Let's see here. Oh, why is it? Do you guys know why it's stopping? Missing one thing. What do we always need in a
Oh,
switch?
it's a break.
Yep. Need a break here. Because if I don't put a break in, it just goes down here and puts this in and makes it an N, and the program ends. Oops, what happened there now? Where's the error at? That's weird. I don't see it. Where's it at? Oh, might not have been. I told you we were going to have to go do that. So where's play again at? So this needs to be initialized to something. I'll just make it equal to a Y for now. There we go. Save that. Now run it. There we go. An A, and I put in 6. Comes back up. Good job. You're correct. I'll do A again, since that's the only one we got built. And this time I'll get it wrong on purpose. I'll put in an 8. And then I'll just hit X to exit. And it says I had 1 out of 2 correct. Okay. So that works. Okay. So again, later on, we're going to cut this down. We have it all in the main right now. Some of this stuff is going to be redundant, okay, in our parts of our switch, okay. So the next one I'm going to do is the easy. Well, I can do this. Let me stub them all in. So I'll say case S. Whoops. And then I'll just type break here. And then case M. Oops. And then a break. Sometimes when I do these, I actually put something in like subtract is here, multiply is here. But again, we build it in stages. And a lot of times I'll just stub this in right away, even before I write any code. I'll stub it in, make sure it's running correctly. Okay. So the next easiest one is multiply, okay? So what I can do here is just go like that, that. And then right here. And I'm just going to go up here and copy everything. Whoa, don't go that far. Right up to here. Control C. Come down here. Click in there. Control V to paste it in there. Okay, and all I need to do is change this to an X I'm going to use because little kids don't know what an asterisk means multiply. And then enter your answer. That is not a valid integer. That's still correct. The right answer will be this with a splat in there or asterisk in there. And the rest of it is fine. So now that one should work. Let's see if it does. So if I type in an M, I get that, and I get a 12. It says good job. And then if I do an M again, and I'll put in a 1, and then I'll hit an X. It says I had 1 out of 2 correct. That seems to be correct. Oh, let's test this now. So if I do an M and I type in the letter A, it says that's not a valid integer. But if I type in 63, it says good job, you're correct. And then again, X to get out of it. So my error checking, my program is not crashing. Okay. So now let's do the S. Well, this one's a little bit different. Let me put this up in the brain. And we'll paste our code in. Whoa, what happened there? I hit it twice. I sure did. Let's undo that. There we go. So this one, before we do anything, I have to do this, okay? So I'm going to say, if num1 is less than num2, then int temp is equal to num1. Num1 will be assigned num2, and num2 will be assigned num or temp. Okay, so this little algorithm so this is I'm trying to think here what I want. Any problem or something. So I'm just switching the order. Okay. This becomes a minus sign. And then, oops. This becomes a minus sign. And let's try that one. So if I say S, say 2, okay. And then S again. And I'll say 1. Next to enter. 1 out of 2 is correct. Notice again that I'll never get a negative number because number 1 always is bigger or equal to number 2. let's get rid of all this mess. And that only leaves us the D down here. And the first thing I want to type in here is if num2 is equal to 0, then num2 will be equal to 1. We don't care about number 1. Number 1, you can divide into 0. You just can't divide by 0. So there's that. And then we can go ahead and paste. Let's see. Oh, no, I'm not. I got something else I want to do first. So int temp is equal to, or not, int dividend is equal to num1 times num2. Okay. And then we'll paste. And we'll go back up to the top here. And we're going to replace num1 here as the dividend. This is going to prevent us ever getting a fraction. Because now what we did is we multiplied the two numbers together, and then we're going to divide by the second number, which will always give us the first number. So here our answer, our computer answer, is just going to be number 1. And so I got that, don't need, so number 1's going to be right there. And then we'll get rid of some of this. All right. And then get rid of, oops, get rid of a lot of this. Okay, so that goes there, that goes there. We can get rid of this for now. Looks like that. Let me just finish this real. So this right here, I'm going to add a line. Something like that. All right, so now let's run it again. This time we're going to divide. And that'll be 9. Divide again. What the hell is that? 9 goes into there 5 times. And then we'll do it again. That'll be 3. We'll do an addition. It'll be 8. Do a subtraction. I'll get this one wrong on purpose. And then multiplication. It's 56, I believe. And then I'll exit. It says I have 5 out of 6 correct. So what do you think? Again, we got a lot of code in here that's that in the future we'll only have one of these, for example. and we'll call it from another module or a different procedure. Same thing down here. But for now, we'll just do it repetitively, and it should be good. It runs good for what it is. All right, so that's, again, this will be online. If you didn't do what we did, you can watch the video later once I get it processed. The other thing I wanted to show you too is this play it again example. I think I have it open. Let me look here. Of course I don't.
For some reason, when I run my multiplication one,
Yeah,
like instead of it going back to like the menu to switch to a different one, it goes straight into division.
because you're missing a break,
Okay. Oh, yep, I am. Thank
right?
you. Yep.
I thought I had that one. Hang on one second here. Move this out of the way. Again. So I also gave you a sample right here of the play it again. So this one just shows you what we had running at the beginning. Okay, where here's your initialization, here's your process, here's your increment, and here's your test. So all your programs from now on will at least have this where your program will run multiple times. Because if I run this one now, you can see this. And if I hit Y, it runs again. If I hit N or any other character, it exits the program. So that's in the above the assignment over in Blackboard. So if you want to get a copy of that, you download it, unzip it, and you have that. So that's my song and dance for today. Again, you really need to study this because this is one of the major things that we're going to use going on, similar to the decisions and stuff like that. So, any questions before we go?
A million, but that might be for another time.
Well, I will be back probably, what time is it now? 10:45. I have an office hour at 11 o'clock to 12 o'clock. So I will be back if you have questions.
Okay.
All right. Did Paul
Thank
ever
you.
wake up?
Yes, it did.
It's good. You were snoring online, dude.
Sorry, Professor.
That's all right. You're okay. All right. I'll see you guys Thursday or in an office hour or in an email. Have a
Thank
great
you, sir.
day.
Thank you, sir.
Thank you. Bye.
Bye.